Hello, we're the RE.Aliens team from Egypt. In this video, we'll be discussing the CoSpace Rescue Under-19 mission in RoboCup Asia Pacific 2023. We will explain each member's role, how we overcome a certain challenge, and how it impacted our success. But first, who are we?
Our team has 4 members. Ahmed Abdul Latif, our strategy planner, who assembles algorithms for our plan. Abdurrahman Muhammad, our programmer, whose duties include writing code for object detection, obstacle and trap avoidance, super object and deposit area positioning. Basmala Ahmed, the project manager, who oversees team rules, documentation, editing, and publications. And that's me, Ahmed Hussein, the team leader and programmer.
Some of our team members has participated in RoboCup 2022 and won the first place nationally and competed internationally. This year, our team participated in RoboCup Junior Egypt 2023 in the CoSpace Open category, and we were able to get second place and qualify to represent Egypt in RoboCup Asia Pacific 2023. Our CoSpace category missions involve programming a robot that delivered parcel in an autonomous and fast way, which was represented as colored objects scattered on the map, where we have to collect them and deposit them. The goal is to collect the greatest number of these objects in the shortest possible time. This will be achieved by focusing on obstacle avoidance, navigation, path planning, object recognition, and object manipulation in dynamic environments. We realized that problems like traps, swamps, walls, and ensuring the robot does not leave the map can be solved using variables generated by the robot, such as ultrasonic sensor that shows us the distance between the robot and the walls, the RGB color sensor which tells us the color the sensor of the robot recognizes so that we can avoid traps and collect objects. This allows the robot to move freely on the ground without fear of becoming trapped or colliding with an obstacle. Our strategy, as shown in the flowchart, relies on the A-star algorithm to locate and compute the shortest path, the attend function with BID controller to drive the robot along the shortest path, and additional strategies are used to enable the robot to reach its destination fast and smoothly. As a result, we were able to succeed in our mission of navigating through the virtual world to collect objects, while competing with another team's robot that is searching and collecting in the same virtual world. And even though we were able to succeed in achieving 1,500 points as an average score.
In conclusion, we observed the great knowledge gained in relation to programming and problem solving. We realized the great relevance we should give to the organization of the code and time. Also, we found that the RRGGBB strategy gave the greatest point, so we relied on it.
The robot have succeeded in navigating the map efficiently and collecting the RRGGBB and depositing it as shown on the screen. And here the robot have succeeded in collecting the Super Plus object and depositing it immediately in the closest deposit area to the robot. As shown on the screen, the robot is avoiding obstacles and map borders smoothly to avoid getting stuck in each of them. In the end of this game, we were able to achieve a score of 2,220 points by collecting 2 Super Plus objects.
During our journey in CoSpace, we succeed in 2 strategies. The first one is dividing the map into sections and using the attempt function to go from one to another and getting the super object with the attempt. But it has a lot of bugs with the walls and obstacles. The second strategy is depending on A-star algorithm to solve this issue. The A-star algorithm helps us to find the shortest path, which saves the time. To implement this, we should use Microsoft Paint to draw the map. Then, using OpenCV to convert the painted map into 2D array. And convert it into weighted array using C++ for being an input for the A-star algorithm to solve the stacks, avoid obstacles, and go to the deposit and the special zones.
Now we are going to explain how to use a TAM function in details. Imagine that our robot stands at a point in the map. This point has a coordinates x1 and y1, and we need that robot to move to another point. This point also got a coordinates x2 and y2. So if we connected the two coordinates together, it will give us a triangle as shown in the picture. This triangle, we know it's delta x, which is the difference in x2 and x1, and delta y, which is the difference in y2 and y1. So we can calculate its angle by tan inverse function. As we know, tan of angle equals opposite divided by adjacent. The C++ has a built-in function called a tan2 to give us the desired angle. A tan2 have two parameters, x and y, and the output of this function is an angle. This angle will be between negative 180 to 180 degree, and the compass sensor in our robot give us its angle between 0 to 360. So we need to shift a tan2 output to an angle between 0 and 360. As a result, we developed a code to solve this issue. Now we got the desired angle and need to turn the robot to this angle. Hence, we use the built-in function in CoSpace simulator called turn2, which takes one parameter. This parameter is an angle, and this function makes our robot rotate to the desired angle.
During our journey, we gained a lot of knowledge, personal and technical. The most important technical knowledge was in pathfinding algorithms, position prediction in block zones, and obstacle avoiding. This knowledge can be implemented or already implemented in GPS to find the best and fastest route by using pathfinding methods. Actually, GPS uses a star but in wide range. Exploration of uncharted environments as a strategy based on collecting objects and finding the best route to many places, such as the orange deposit area. So, if we implement this in wide range, we can use it to navigate many places, like navigating Mars planet. These applications highlight how combining pathfinding algorithms with sensor data and advanced technologies can enable accurate positioning, obstacle avoidance, and efficient navigation in challenging. Artificial intelligence is one of the most important tools that is used to make searching easy and more efficient. During our journey, we used 3 AI tools, which are ChatGPT, to provide us with information about a specific thing, and with initial codes that after modification can be used to solve many problems. Google Bard, this amazing AI tool, gave us many videos that we use to understand many things, like explaining a star algorithm, the weighted map generation, organizing presentations, and other things. Neural Doodle, this tool is used to create more code-based maps to test the code efficiency. Let me say that these AI tools helped us greatly in developing our code and fixing the errors that we faced. During our journey, which takes a year, we have learned a lot of things from the competition, work, our coach, and even from each other. So, we want to thank everyone who was a reason for our participation in this competition. And a special thank for our sponsors, Masr Al Khair Foundation and the Heidelberg Materials Egypt. Also, we learned a lot of skills like time management. This skill helps us in finishing multitasks in the best way. Learning the concepts of code priorities is one of the most important skills that reduce the logic errors in the robot performance.
Pathfinding algorithms are one of the most important things in the AI era, as it's used in robots, cars, and airplanes. OpenCV library in Python is the main library in AI. It helps us to convert the map into 2D array.
If you want to know the rest skills, you should participate and let the journey teach you what you need to learn.
And thank you, RoboCop.